Okay, so we are doing 2.9. So we're doing operations with I, like with imaginary numbers. And basically, all you got to do is treat I like a variable, like X. Just treat it totally like a variable, okay? For anybody who needs, this is page 133. Okay, page 133. Alrighty.
I forgot my book, so can I do it on a piece of paper?
Yeah, piece of paper is fine. Okay, so now, look, I like to underline my like terms. Actually, I can highlight here. So 3 and 6, those are two terms that have the same letter situation. Okay, that's what I call it, letter situation. All right. And then you have 4i, negative 2i. Those three have the same letter situation, which means that their letter is I. Okay? So we can combine these. 3 plus 6, that's 9. 4 plus 4 minus 2 is 6. And then the I is still there. Boom, done. Okay? At the end, you guys, just make sure that your imaginary numbers are in, your complex numbers are in A plus BI form like that. Okay, like 9 plus 6i is. Okay, number 2. Same thing, you guys, just keep it going. Except now I have an I that I must first distribute. So I do. And I get negative 3i plus 7i plus 5i squared. And then now I go look at my letter situation. Okay? Okay, let's talk about that. Because you guys, I'll write it in black up here so you remember. Anytime we multiply an I times an I, we get I squared. Okay? The same way that X times X is X squared. Okay? So over here I had an I and I multiplied it by 5i. That had an I times I became I squared. Now, if it was plus though, I plus I, nobody becomes squared. That's just 2i. Okay? Or the same as like right here where we did 4i plus 4i minus 2i. We didn't end up with anybody becoming squared or cubed or anything. That doesn't happen when you add. Okay, let's go look at who's got the same letter situation. Negative 3i, positive 7i, they have the same letter situation. And then 5i squared, that's a different letter situation. So they're not like terms. This is 4i plus 5i squared. And this is as far as we can simplify it using my treat I like an X thing, all right? But then once you reach this point, we're not actually done because we do need it to be A plus BI. So I squared is not allowed. So then the number one thing you need to remember is that I squared equals negative 1. Which means this is 4i plus 5 times negative 1, because I squared is negative 1. Which means that this is 4i minus 5. Which is cool, except it still doesn't look like A plus BI. What's wrong with it? Yeah.
It's like, you gotta flip them.
You gotta flip them. They're the wrong order. It's nitpicky, it's annoying, but it matters. So you actually have to, and the sign goes with the number after it. So the negative 5 plus 4i. This is A plus BI. Okay? Okay. Number 3. This is one I feel like we can skip because it is similar to 1 and 2. After we address that very innocent looking negative right here. That thing's pretty harmless, right? No, it's not. It's not harmless at all. This thing got me a lot of questions wrong when I was in high school, all right? Because I would just write minus 3, I would write 5 plus 2i minus 3i plus 8. And I would be wrong. You need to distribute the negative, you guys. The negative's going to go in and change everybody's sign inside those parentheses. Notice, I didn't say it's going to make everybody negative. I said it's going to change everybody's sign, because if somebody was negative, now they're positive, okay? So think of it as change everybody's sign. This is minus 3i minus 8. From here, you do the same, comparing letter situations that we did in numbers 1 and 2, okay? Okay. Moving on, you guys, number 4 is also very similar. I'm just going to do a quick peek. Maybe I'll do B and D. But I'm not going to do all of them because I think you guys can do it. Okay, so in B, step 1, you got to distribute the I. All right? So I get 2i plus 3i squared plus another 2i. And then 2i plus 2i, that's 4i plus 3i squared. But you guys, I'm going to throw out that I squared and put a what in instead? -1, remember, it's still up here. I squared, just toss it out, put a -1. So that isn't plus 3, it's actually minus 3. 4i minus 3. And the orders is messed up, so I'm just going to flip it to be -3 plus 4i. Perfect. And so there it is right here. That first one is B. I'll also do D before we move on. So for D, I have 4i plus I. Look at this -3 that I have to distribute. You do have to distribute the negatives, you guys. This is a big place where we make mistakes. So this becomes -6 minus 3i. And then the plus 3 is left there. Okay? I just got the urge to do this. Highlight for you where that came from. Okay. And now we go simplify, combine people with the same letter situation. So 4i can combine with -3i and the plus I. And then -6 and +3 can combine. So -6 plus 3, that's -3. 4i plus I is 5i, minus 3i is 2i. That's it for D. So that's actually the next one down. Okay, any questions, you guys? All good? Okay, so now we're moving into this. Which of these complex numbers is equivalent to this guy? Okay, let's go see. So first, distribute the 4i. That's 8i plus 24i squared minus 13i to the 5th. Holy moly. 8i, that one's fine. But these guys are not fine. There's no I squared in a plus bi. There's no I to the 5th in a plus bi. So I gotta go and think about this. Remember this pattern, you guys. It went I, -1, -I, 1. What was this pattern? It was what I to the first equals, what I to the second equals, what I to the third equals, and what I to the fourth equals. And then after that, we just repeat. I to the 5th is here. I to the 6th is here. I to the 7th is here. And this is the key. Every I to the multiple of 4 is down here. And then from there, you trace it back to the others. So I to the 5th, that guy's just I. I'm going to rewrite this as negative 13i. And 8i is 8i. And then since I squared is negative 1, this is plus 24 times negative 1. So this is 8i minus 13i. That's negative 5i. And 24 times negative 1 is negative 24. So you wouldn't have known it just looking at it, but it is equivalent to B. Okay, any questions there? We're getting these I to the higher power stuff. It makes sense? Yeah? Okay. Okay. We're gonna look at number 6. Bao is claiming that a minus I to the 7th is the same as 8 plus I to the 9th. Well, let's see. I to the 7th is negative I. And minus minus becomes plus. And then here, 8 plus 9, 8 plus I to the 9th is 8 plus, okay, I to the 9th, if I follow the pattern, since I to the 8th is here, I to the 9th is here. That's just I. And look at that. Totally correct. They are the same. Okay. You guys, number 7 is an interesting question. It's a good one. It's not one I want you to lose sleep over. All right? But to go over it real quick, they want us to use the digits from 0 to 9, each only once, to create the smallest real number that I can. So the fact that they want the number to be real means that it can't have I in the answer. And looking at this up here, my even powers of I are real numbers. You see? So if you don't want an I in your answer, I would go with an even number where the exponents were. But even better, if I want a small number, should I pick ones that make negative 1 or positive 1? Negative 1. Negative 1 is smaller than positive 1. So here's the first thing I'm thinking. 2 and 6. I want those for my exponents. That's gonna be one of the seconds that I cringe when I watch the video, but I'm not gonna do. Okay, all right. So I'm gonna make one of the exponents 2 and one of them 6. What that's gonna do is turn this portion of each of these into negative 1s. Does that make sense? Because I to the 2nd and I to the 6th are both negative 1 right here. And the reason I picked 2 and 6 was because out of all the options on real numbers I could pick, this came out the smallest. Negative 1 was the smallest I could get. And now I've got the opportunity. What's bigger, you guys? Like a negative 9 or a negative 1? Negative 1. Yeah. So now that I've turned negative here, these two spots, hold on, I'm not showing it, am I? Okay. Since I've got negatives here now, I actually want these numbers to be as big as they can be. That 9 and the 8, I'm going to throw them there so they become negative 9 and negative 8. And then these spots, these are positive numbers no matter what I do. I'm going to use my smallest numbers for those, 0 and 1. So I would get 9 times negative 1 plus 1 plus 8 times negative 1, which is negative 9 plus 1 minus 8, negative 16. I mean, I believe that's the smallest number you can get. Like, that's you maximizing the digits, like you making the best use of the digits you have to make numbers as small as possible. Again, don't lose sleep over these questions, okay? The spiral review, they're usually very good for what's coming up, but I don't want to spend a ton of time on it. I guess just enough to tell you distribute the negative 3, you guys. This is negative 3x squared minus 12. That's all they want. They just want you to multiply it. Over here, do this. Some of you like FOIL. I don't like to say FOIL. I just like to distribute. Distribute the 2x, distribute the negative 3. And then for this one, remember that it's 5 minus 6x, 5 minus 6x. Okay? Okay, so I'm going to stop this one.